Okay, continuing lesson 13 on angles in similar triangles. If we know that two triangles are similar, we can set up and solve a proportion. So we're going to bring that back, okay? We're going to be solving some proportions today. So in each of the problems, determine if they're similar, explain, and then set up a proportion, okay? So I'm going to give you a hint here. Find all three angles of the triangle, okay? So if I add 47 and 68 together and subtract 180, I get 65. If I add 65 and 47 together and subtract from 180, I get 68. Okay, so I don't need all three, but I need at least two. Wait, the three is going to help us in a little bit. So we're going to say yes, two pairs of corresponding angles are congruent. Okay? All right, so here's our proportions. We are looking for x. I'm going to try to place that question mark with an x. So I'm going to go x, line under equal sign line. We're going to set up two proportions here. Okay? So try to remember back when we were doing this before. X is between the 68 and 65. If I come to this triangle, 10 is between the 68 and 65. So I'm going to line the x up with 10. I need another number on the same triangle as x. That's 12. 12 is between the 68 and 47 angles. Between 68 and 47 is 15. Proportion set up. Now solve. Cross products. 15x equals 10 times 12, which is 120. Divide both sides by 15. X equals 8. Just like that. That's what we're going to be doing. Okay, so let's look at a few more examples. If I add these together and subtract from 180, because all three angles have to add to 180, I get 48. If I add these together and subtract from 180, well, you know what? Honestly, it doesn't even matter what I get, because look at it. I'm only going to have one pair that's the same. So, are these congruent? No. Only one pair. I keep wanting to spell Paris. Of corresponding angles is congruent. Okay? So guess what? We don't even have to do the last one. We'll just say not enough info. Okay? All right, let's look at this one. Now what I want you guys to see here is this is back to some angle relationships. If I extend these lines out better than I did up here, these are alternate interior. So if this is 37, this is 37. If this is 52, this is 52. So guess what? Yes. And for the sake of time, you guys write out the explanation. Okay? I'm just going to put that. All right, so we're looking for x right here, right? So I'm going to go x, line, equal sign, line. So if I find all three angles, right, and I add these together and minus it from 180, that's just helpful. And these are vertical, so that's 91 as well. That's helpful for saying what x corresponds to. X is between 52 and 91. So is 12. See, 52 and 91, 52 and 91. So I put the 12 underneath. On the same triangle as x, well, that's also a 12. So I line it up right across from the x, remember, horizontally and vertically. 12 is between 37 and 91, and so is 16. Once you get to this point, guys, it's cross products. X times 16, or 16x, equals 12 times 12, which is 144. Divide both sides by 16, and we get x equals 9. Okay? Last one, pay close attention to, okay? Because what I want you to do is I want you to take these two triangles apart. Here's what I mean. All right, so see NEQ here? I'm going to rewrite it right here. Okay? And then I'm going to take the big triangle here, and I'm going to do that one too. Okay? So this is NQE, and this one is NIC. A lot of times it's easier to see it when they're not on top of each other. Okay? So pull them apart. We can look right here. This is 6, and this is our x. Now be very careful. Hint here. This side is not 9. Remember, 9 is only part of it. This, from N to C, how far is that distance? Well, it's 9 plus 6, which is 15. setting up a proportion, x goes to 20, and 6 goes to 15. Using our cross products, 15x equals 6 times 20, which is 120. Divide both sides by 15. X equals 8. Okay? Oh, sorry. This was a yes up here, too. And this info goes in here. All right. So setting up proportions, once we have similar triangles, we can set a proportion to find a missing side length.